The next topic is how do you project a plane? First, project the corner of the plane on the plane of projection. Then join those corners, give the projection of plane. Now consider a equilateral triangle, corner A, B, C. Now first project the corner of the plane A, B, C. For example, project the corner of the plane A, B, C. Then join all the corners. Join all the corners. That gives a plane of projection. That gives a plane of projection. Next, what are different position of plane? Different position of planes or location of planes. How do you locate the plane? How do you locate the plane on the planes? The first position is plane is parallel to one plane. Here, instead of if you confusing the plane, the word, better you go for take a lamina. Lamina is parallel to one plane and perpendicular to another plane. So how do you say the line is parallel to one plane and perpendicular to another plane? If I say plane is parallel to one plane means the distance of each corner of a plane to the plane of projection that distance should be equal. The equal distance of the distance of each corner of plane to the plane of projection is equal. Then they say the plane is parallel to the plane. Perpendicular to the plane means all corners of a plane lies in a straight line or straight path. Then you can say that the plane is perpendicular to that plane. This is how do you say the plane is parallel to one plane and perpendicular to another plane. Now consider a triangular lamina. You can see the shadow of this triangular lamina. Now that each corner of the plane is equidistant from the horizontal plane, then you can say that this plane is parallel and is also called as it is also called as a true shape. When we say the true shape means the actual lamina, whatever the actual size of the lamina, when you project on that plane, the projected portion, the projected plane is also actual shape. Then it is called as a true shape, right? Then second position is plane is or lamina is inclined to one plane and perpendicular to another plane. Lamina is inclined to one plane and perpendicular to another plane. Now consider same triangular lamina. Now this is parallel to the plane. If you go for make the lamina is inclined to HB. Now see the shadow will not the actual shape of the lamina or true shape of the lamina. This shape is called apparent shape of that plane. Then it says that the plane is inclined to one plane. If you project it in vertical projection, then all the corners of the lamina lies in a straight line. Then the third position is lamina is inclined to both the planes. The lamina is inclined to both the planes means I can consider the same triangular lamina. Initially it is parallel to one plane, now it is inclined to horizontal plane, now the lamina is inclined to vertical plane. Now again that lamina, the shadow of that lamina, you can see that will not get the actual shape of them. Now you can say that the lamina is inclined to both the planes. These are three different positions of the planes. And if you go for take examples where we see that first one, the plane lamina is parallel to one plane and perpendicular to another plane. For example, if we consider photo frames, wall clock, mirror. Now these are the objects which are parallel to VP and perpendicular to HP. Is it right? So plane is parallel to one plane, perpendicular to another plane. Example, photo frames, wall clock, mirror, etc. So these are parallel to VP and perpendicular to HP. Similarly, go for second example for second one. Lamina is inclined to one plane and perpendicular to another plane. Example, take doors. The small opening of the doors or windows. So if you open the doors and windows at a certain position, now you can say that the door is inclined to vertical plane and perpendicular to horizontal plane. This is the example for inclined to VP and perpendicular to HP. A small opening of doors and windows. When it comes to third one, can you guess any example for a lamina inclined to both the planes? Can you give some example?